Welcome and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star 1 on your phone to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Katherine Hambleton. Thank you. You may begin.
Thank you and good afternoon. I'm Katherine Hambleton with NASA's Office of Communications. Thank you all for joining us for our announcement of the regions NASA has identified for landing the next Americans on the moon during Artemis 3. Within these regions, there are multiple potential landing sites for Artemis 3 where the first woman may set foot on the lunar surface. Today we will announce the regions near the lunar South Pole that are under consideration for an Artemis 3 lunar landing, bringing us one step closer to returning humans to the moon. You may reference our press release about Artemis 3 landing regions on nasa.gov that was issued shortly before this call for visuals and additional information. Joining us on the line today to provide more details are Mark Kirsich, Deputy Associate Administrator for the Artemis Campaign Development Division at NASA headquarters, Jacob Bleacher, NASA's Chief Exploration Scientist at NASA headquarters, Sarah Noble, Artemis Lunar Science Lead for the Planetary Science Division, NASA headquarters, and Prasun Desai, Deputy Associate Administrator for the Space Technology Mission Directorate at NASA headquarters. Each speaker will make brief remarks, and then we will open the lines for questions from reporters. For those on the line, please press star 1 at any time to enter the queue to ask a question. Please remember, when we come to the questions, to state your name and affiliation and address the speaker you'd like to answer your question. We do ask that you please stick only to one question so that we can get to as many reporters as possible, and you may enter the queue again to ask additional questions if we have time. First, we'll hear from Mark Kirsich. Mark?
All right, good afternoon. Thank you, Catherine, and welcome to everyone who is joining us today. It's particularly exciting for me to talk to you on the eve of Artemis 1. As you all know, in just a little over a week, hopefully next Monday, the first flight of the Space Launch System, the SLS, and the first lunar orbital flight of Orion will take place, setting in motion a series of missions that will return people to the surface of the moon for the first time in over 50 years. And I know, well, many eyes, including mine, by the way, hands, arms, cameras, iPhones, they're all focused on that beautiful vehicle in Florida. If you haven't seen it today, take time to look at it because it is quite a sight. But today, my science and technology colleagues who are on the line with me today, and I and others throughout the agency, we've been focused on what we're going to do on the future missions. And that leads us today. Today, Jake Bleacher, Sarah Noble, Prasun Desai, and I are here to announce some really exciting news. The 13 specific regions around the South Pole of the moon that we have selected as potential Artemis 3 landing locations. Artemis mission planners, people that work with me, NASA's Human Landing System program at the Marshall Space Flight Center, and their prime contractor, SpaceX, have worked very closely with our agency's scientists and technologists to identify these 13 regions that you're going to hear more about today. And what you're going to hear more from our other speakers, that all of the regions that we have selected, all 13, have both utilization value, and what that means, they're of value to the scientific community and the technology community. People want and need to do things there, as well as meet the Artemis mission planning constraints, which can be challenging. This will be the first time we will land a human lander at the South Pole. It will be the first landing of a Starship, so we have to pay close attention to the engineering and safety constraints of the mission and the vehicle. First, some background on our plans to how do we get from today to that Artemis 3 landing? Well, it all starts in Florida a little over a week from now. You know about that. Artemis 1, the first SLS flight, and the first Orion lunar orbital flight will demonstrate key capabilities of both of these vehicles. And it's extremely important. It's a very thorough, very rigorous test that will check out all the systems that are important to put humans on for the first time. About 2 years after Artemis 1, in 2024, we will launch Artemis 2, which will be the first time people will ride aboard Orion, and also the first time that people will return to the moon since Apollo 17, an extremely important flight that will set the stage for the follow-on Artemis mission. About that time, shortly thereafter, SpaceX, our prime contractor for the uncrewed for the human landing system, they will perform an uncrewed with no people on it test of the HLS. That will be extremely important. And all of this culminates in late 2025 with our Artemis 3 flight, which will be our first Artemis crewed lunar landing, marking the first time a woman will walk on the moon, and also the first time we humans have visited the South Pole region. We've talked about this before. You're going to hear more about this today, but we're going back to the moon for several reasons. First of all, for science discovery, to learn more about ourselves, more about where we came from, planetary processes. We're going to advance technology. Things we'll do just in creating the vehicles and systems that support people, but also things we'll do specifically on the surface of the moon will advance technology to help all people. And also, we're using this experience to prepare for a trip to Mars. We're going to demonstrate the systems we need. We're going to learn how to adapt, protect, and take care of the human body. And we're also going to learn how to use lunar resources to get to Mars. Our Artemis 1 and 2 missions will demonstrate the Space Launch System, Orion, our exploration ground systems, and also the space communications and navigation networks we need to do this mission. But to accomplish the actual lunar landing, we will add 2 more key elements before Artemis 3. One I've mentioned briefly, the human landing system, and also our exploration spacesuits. SpaceX, as I mentioned, will provide the Starship, what's known as the Starship Lunar Lander, and they are very much into the development of that lander as we speak. And we, NASA, just recently selected 2 companies, Axiom and Collins, that will build spacesuits. Now, when we selected the companies, there are actually 2 different suits we'll be developing via this contract mechanism, one for the International Space Station, and one we will use on Artemis 3 when we people walk on the moon for the first time. Talk a little bit about the Artemis 3 mission. It's different from the Apollo mission. In the Apollo mission, the elements we needed were all launched on a single Saturn V launch vehicle. And in our architecture, it's a little bit different. If you've seen the Starship concept, the SpaceX will actually launch a fuel depot that will orbit the Earth, and then they will launch tankers, which will fill up the fuel depot. And when there's the amount of fuel we need in Earth orbit, the actual Starship that will take people to the surface of the moon will launch from the Earth and will fill up with gas, if you will, in Earth orbit. It then travels to the moon, and it enters the orbit that we'll use to conduct our lunar operations from. It's called the Near Rectilinear Halo Orbit, NRHO. We use that acronym. It's a very stable orbit around the moon that gives us a very long look over the South Pole where we'll be landing. Once we've confirmed that the Starship is there and ready to receive the crew, then we will launch SLS on Orion from the Kennedy Space Center. Orion will travel to the moon and dock with the Starship in the NRHO orbit. We will spend a couple days docked, and then 2 of the crew will transit from Orion into the Starship, undock, and land on the moon. On the surface of the moon, we'll spend 6.5 days. The crew will do work both inside and outside the HLS. Outside, we'll be doing field science, deploying instruments, collecting samples to bring back to the Earth. Inside, we will do various observations of the human system and how they're adapting to the lunar gravity. At the end of approximately 6.5 days, the Starship will lift off from the surface of the moon, rendezvous with Orion and the NRHO. We will transfer the crew back into Orion, and Orion returns and lands in the ocean off the coast of San Diego, just like we will do on Artemis 2. The subsequent missions we're flying are going to build on what we accomplished during this flight. Right after Artemis 3, we'll begin the buildup of the Gateway. The Gateway, as you know, is an outpost in lunar orbit that we will also use for science experiments, technology development, and also for Mars demonstrations, key Mars demonstrations. Gateway will allow us to spend more time in the lunar environment, so it gives us a longer stay capability. We'll be adding over the years additional surface elements, rovers. Rovers are extremely important because they give the crew mobility. We'll be able to travel tens of kilometers to explore. The crew will be able to explore different areas of the moon and a habitat for longer stays. We'll be developing key technologies demonstrating surface power, in situ resource utilization, and more advanced science taking advantage of these infrastructures. And all of these things are important for our goals, to develop this deep space economy, which is important to us, enhancing and maintaining our national leadership in space, and to help us on our long-term goal, sending humans to Mars. So with that introduction, now it's time to learn more about these 13 regions and where we may land. And to go more into that, it's really my pleasure to introduce a person I've worked with closely on this topic for a little over 2 years. It's the agency's Chief Exploration Scientist, Jake Bleacher. Jake.
Hey, thank you so much, Mark. And as Mark said, it really is a pleasure working with everybody on this. And I've said several times this week, I feel like we're on a roller coaster that's about to pass the top of the largest hill. I mean, buckle up, everyone. We're going for a ride to the moon here. In 2009, NASA launched the Lunar Reconnaissance Orbiter, which we lovingly call LRO. Our friend LRO, it's important to remember, was a joint endeavor between science and human exploration. In addition to all the science, it was in part sent to collect the data needed to help us decide where to land future spacecraft. Well, LRO did its job well, as have all of our human and robotic predecessors whose shoulders we now stand upon as we gaze into this new era of space exploration. NASA was given the challenge to land in the south polar region of the moon in order to take advantage of unique environmental conditions that provide greater than average amounts of sunlight, conditions that provide us with access to volatiles that will unveil new secrets about our solar system, while potentially also yielding valuable resources that can help support the emplacement of future infrastructure like Mark talked about. This course was set for us in order to begin building a blueprint for exploring the solar system through collaboration with partners in industry, academia, and our international partners. NASA will not do this alone. NASA will lay the groundwork for humankind to explore and learn about our place in the universe. But what is so exciting about the south pole of the moon? Well, to explain this, we kind of need to take a mental walk from the equatorial region of the moon to the poles. I think most space enthusiasts are familiar with Apollo views of the moon. Astronauts, rovers exploring fantastic features of the moon, features that are all bathed in sunlight as far as the eye can see. However, at the poles, the lunar seasons, coupled with an extremely low axial tilt for the moon of about 1 to 1.5 degrees, they yield a much different scene. At the equator, a lunar day spans roughly 14 Earth days of continuous sunlight, followed by about 14 Earth days of continuous darkness. That's on the order of 330, 340 hours of sunlight and darkness, repeated over and over. Nearly every place near the equator has a 50-50 split of light and darkness. During the daytime at the equator, you're completely in sunlight. You move a mile over there, 5 miles back here, you remain in sunlight. At the poles, the lighting is different. The ratio of light to darkness can vary significantly. It ranges from permanent darkness, locations that never see sunlight, to nearly complete exposure to the sun through a lunar year. What makes this situation even more complicated is that the ratio of light to darkness at any location, well, it varies over short distances. In as little as a few miles, sometimes even short distance like a football field, that ratio can be drastically different. While these sunlight conditions might sound complicated, thanks to LRO and our other spacecraft at the moon, these conditions are predictable. Although some locations might be dark most of the year, we will know when they are going to be in the light. While it might seem complicated, it's these very conditions that provide us with the rationale for going to the South Pole. Finding locations with greater than average amounts of light enable us to design systems that take advantage of light for energy and thermal control. Similarly, locations in permanent shadow, which are unique to the poles, provide opportunities for access to water and other volatiles that are trapped there, but they don't become stripped away by the solar wind. Although these conditions can be modeled and predicted, I think you can imagine many different technical considerations must be made in order to land here. For this reason, in 2020, NASA organized a multi-directorate group to coordinate among our different technical teams that were modeling potential lunar landing conditions. This team is called the Cross-Artemis Site Selection and Analysis Team, or CASA. CASA is our home for coordination between multiple directorates and the technical experts who have been assessing possible landing locations for Artemis 3. CASA includes representatives from the Exploration Systems Development Mission Directorate, Space Operations Mission Directorate, the Artemis Campaign Division, the Science Mission Directorate, and Space Technology Mission Directorate. Including both myself and Sarah Noble, who will speak next. We also have Tamara George from the Artemis Campaign Division, Brad Bailey from Science, and Jonathan Bowie from the Space Technology Mission Directorate. CASA, working closely with our technical experts across the directorate, identified the technical considerations for evaluating landing locations. In addition to exposure to sunlight throughout the mission duration and access to volatiles, we additionally considered low-slope terrain, Earth visibility for communications, landing accuracy, resolution of available surface data, combined vehicle mission capabilities of the Space Launch System, the Orion, and the Starship Human Landing System, all of this being considered within 6 degrees of the lunar South Pole. Because there are no locations of permanent sunlight, none of these regions are accessible continuously at every launch opportunity. So we can't go to one spot regardless of when our launch window comes up. I like to think of the South Polar region as a target-rich environment. As such, throughout this process, we've identified 13 regions that are accessible for Artemis 3 at various times throughout a lunar year, and we'll continue to work in partnership with SpaceX to further evaluate these regions. We define a region as a surface location about 10 by 10 miles, 15 by 15 kilometers. And each one of these includes several landing sites, which are on the order of basically the landing ellipse of the vehicle about 100 meters across. So a region might be considered as a series of parking lots, while a site is a single parking spot for a lander. As Catherine noted at the beginning of the teleconference, NASA released a video and an image that highlight these 13 regions just over an hour ago. Please refer to these products to see the exact locations of those regions, and I will reference them now from left to right. NASA is excited to announce the following 13 regions of potential locations for the landing of Artemis 3. The rim of Amundsen Crater, the northeastern rim of Nobile Crater, called Nobile 2 on the image, the western rim of Nobile Crater, called Nobile 1, the Leibniz Beta Plateau, the rim of Falcini Crater, an elevated region between the Shackleton and Slater craters, Malapert Massif. We have 2 regions along a high-standing ridge that connects the Shackleton and Degerlache craters, the rim of Hallworth Crater, 2 locations along the rim of the Degerlache crater, and a massif between Degerlache and Kocher craters. All 13 regions are favorable with respect to the landing considerations. Additionally, as the first landing in the South Polar region, Artemis 3 will provide unique new opportunities for both science and technology activities. We also hope that by sharing these locations publicly, we can begin collaborating broadly on assessments of the value of going to any of these regions for Artemis 3. Now, I want to cite a quote here. Knowing that Apollo 17 would be the last Apollo mission to the moon, Apollo 17 astronaut Eugene Cernan reflected on his expectations. At that time, he stated, "The theme of our mission is that this isn't the end. We've just begun to crawl with the Apollo program. We're just now hoping that we can begin to walk as we press on into the future." Well, sir, we accept the challenge. Skylab, Shuttle, the International Space Station, they have all taught us how to survive and thrive in low Earth orbit. We're now ready to take that walk. Discussing the regions where Artemis 3 mission can land is our exciting first step on that path. Now I'd like to hand the discussion over to Dr. Sarah Noble. Sarah is our Artemis Lunar Science Lead from the Planetary Science Division at NASA headquarters.
Thanks so much, Jake. I'm so happy to join you today to talk about the great science that our astronauts are going to be able to accomplish at the lunar South Pole. You know, Jake and I have looked at each other a number of times over the last couple of months and thought, boy, things really are getting real. And it's really exciting to be able to get to this place where we can start talking about this with the community. I want to emphasize, first of all, that this is a new part of the moon. It's a place that we've never explored. It's a long way away from the Apollo sites. If you think about Apollo, all 6 Apollo landing sites were in the sort of central part of the near side. And now we're going someplace completely different, in different and ancient geologic terrain. And more than that, Jake talked about how the poles are unique because of the lighting conditions there. And that extreme lighting conditions leads to really extreme temperatures inside some of these craters where the sun has literally not reached for billions of years. And some of the coldest places in the solar system exist there. And those cold chaps are places where we believe that water and other volatiles get trapped. It is so cold there that molecules bouncing around the moon bounce into one of these cold traps and can't get back out again. And so we are very excited, not only for, as Jake talked about, as a resource, but also from a science perspective to understand what is present in these places. Where did that water come from? How did it get there? Where has it been? What is happening not only on the moon, but across the solar system? How is water moving around? And so we're really excited to figure out what science we're going to do at these 13 regions. We can do exciting science at all of them. We can access these ancient terrains. We will be able to access water and other volatiles that we'll be able to collect, seal, and bring home so that we can study them here in our labs on Earth. So I already know that many of our scientists have gotten hold of this press release an hour ago and are poring over it. I've seen some of the comments on Twitter. Everybody already has favorite places. And as they start looking at these sites, they will find many of them are familiar. Many of these are places that the science community has been talking about for years. And as we look towards our next steps and start diving down deeper into each of these regions, we're really looking forward to hearing from the science community about all the great science that can be done at each one of these individual locations so that they can help us prioritize. We are already in the works of planning a workshop early next year to really engage the community with the goal, of course, of finding locations that are both safe to land and full of exciting science to explore. We're really excited to start those conversations. We'll be starting them already next week at the annual Lunar Exploration Analysis Group meeting, and I really look forward to hearing from the community. So now I'm going to turn it over to Prasun Desai from the Space Technology Mission Directorate to talk about technology, infrastructure, and the future.
Good afternoon. This is Prasun Desai. The Space Technology Mission Directorate enthusiastically is participating in these discussions to understand and ask questions about how the selection of Artemis 3 landing regions and landing sites down the line may affect later missions. From STMD's perspective, we need to proactively plan and develop technologies and make them flexible enough to function in multiple regions. STMD is already investing in and advancing key technologies relevant to later flights. We use our entire portfolio, including the Lunar Surface Innovation Initiative, to mature infrastructure-related capabilities for a sustainable lunar presence. One key area is power. We're developing technology to improve solar power, like the vertical solar array effort that's ongoing right now, to mature deployable solar array technology alongside participation and partnership with industry for use on the moon. We're also collaborating with the Department of Energy to develop nuclear power technology. And we recently announced 3 awards to 3 companies to develop preliminary designs for fission surface power systems that could be used on the moon. Power is limiting all other activities, so this is one thrust for us initially to provide the power that allows all the other systems to operate and work. And so this is where a lot of our energies are being put into at this point. The Science Mission Directorate's Commercial Lunar Payload Services, CLPS, initiative is key for getting our technologies to the moon to test. We have quite a few payloads manifested on upcoming CLPS flights. One that we're very excited about is the in situ resource utilization realm, which is Prime 1, which is a combination drill and mass spectrometer to drill into the lunar regolith and analyze it for water and other compounds. Some examples of the types of questions we ask related to the landing regions are, do the landing regions include multiple sites for both human and robotic landers? What impacts could plume surface interactions have? What are the terrain conditions in the landing regions regarding in situ resource utilization opportunities? And how could the terrain affect solar power production? SDMD looks forward to the upcoming discussions with the broader community. Through the Lunar Surface Innovation Initiative and Lunar Surface Innovation Consortium, we collaborate with industry, academia, across government to develop the technologies needed to explore the moon and with both human and robotic explorers. The Lunar Surface Innovation Consortium is operated by the Johns Hopkins APL facility, which is also hosting next week's LEAG meeting. With the eventual site selection, we aim to learn everything we can about the terrain, lighting conditions, communications, and more to further improve the development and demonstration of technologies such as in situ resource utilization, solar and nuclear surface power, excavation and construction, as well as all the other systems that we will need for sustainable presence on the moon as we go forward. With that, I will pass to the next speaker.
Thank you, Prasann. We will now open the line for questions from the media. For reporters on the line, you can press *1 to get into the question queue to ask your question. Please remember to state your name and affiliation and address the speaker you'd like to answer your question. Again, we ask that you please stick to one question at a time. You may enter the question queue again and ask an additional question if we have time. You can also press *2 to be removed from the queue if you no longer wish to ask your question. So first we will start with Marcia Dunn from the Associated Press.
Oh, hi. Yes, I think for Mark, just Artemis 3 general questions. What happens to Starship after it brings back the crew and is back in orbit and has dropped the crew off in Orion? Does it go back to the fuel depot? Does it come back to Earth? I'm just curious what happens to it, and will it be taking logistical gear down to leave behind on the lunar surface for future crews? Thanks.
Yeah, two great questions. I'm going to address the latter half first because I know more about it. The Starship, if you've seen it before, is a big spacecraft and it has a lot of capability. So there are plans for when the Starship lands, it will include both utilization hardware for us, science experiments, technology experiments, and also SpaceX may include their own cargo they bring from the Earth. They could, like, for example, other commercial instruments down to the moon, and they would coordinate all that with us. I have to be honest, I am not up to date because I know the HLS program has been working with SpaceX on the plans. Eventually, we'd like a reusable Starship. I don't know exactly where we are for the Starship disposition after Artemis 3. We can get you that answer, though. If Catherine would help me, we will get that. I know there are people working that, but thank you.
Thanks, Mark. Marcia will follow up with you offline about that one. Our next question is from Jeff Faust of Space News.
Yeah, good afternoon. Question for Mark or whoever else. I'm just curious, how close to the Artemis 3 launch will you actually select the actual landing site for the mission, and will that landing site vary on a month-by-month or season-by-season basis based on lighting conditions? Will you basically have sort of like a rotating set of potential landing sites you would choose from based on when Artemis 3 actually launches? Thanks. Yeah.
Great question, Jeff. Our plan right now is we would like to firm up our landing sites, and I'm going to say plural, about 18 months prior to the launch. And the reason that is because we will spend time developing more detailed, once we know the regions, the sites we want to go to, we will spend time writing procedures, developing flight plans, training the crew, and that takes some amount of time. So end of our target is end of 2025, late 2025 for this mission. Sometime in 2024, we'll narrow down the list. We will have to, just because of what you heard about today, because of things like lighting, the seasonal variations, where these landing sites are, how they move in relation to the Earth, the look to the Earth, if you will, all of that changes. So we will have to have, likely even for a given launch day, perhaps one or two sites, but we will have a collection of sites that we can use along a launch period, a series of months, just like, for example, Artemis 1, they have other day opportunities. We'll be looking at that too. We will be more than one. Exactly how many, we don't know yet. We have a lot to learn in between now and then. So we have a lot of mission planning work, a lot of coordination across our groups.
Thank you, Mark. Our next question is from Kenneth Chang of New York Times.
Hi, thank you. I was wondering what are the operational constraints of where Starship can land? The crater density, the angle of the slope, craters, and so on.
Yeah, that's a great question too. That is the latest entry in terms of our mission planning constraints. We on the NASA side have been at this landing site planning since the Space Council announced several years ago we're going to be going to the South Pole. It was just recently. When I say recently, it's been several months. It brought SpaceX into this, and we are learning about their vehicles' operational constraints. In our early studies, we used government estimates, and now we're pulling SpaceX in as well. And as they're learning about their vehicle, they're early in their design. What I really rather do on this one, Ken, is this one I'm going to defer. I'd suggest if we want to know more at the moment, we pull in SpaceX or set up a discussion between SpaceX and you on this. It's still early for us to be talking exactly about their vehicle constraints.
Thanks, Mark. Our next question is from Irene Klotz of Aviation Week.
Thank you. On a related note, probably for Jake, what determined the 100-meter landing ellipse?
So those are values that we actually had in our requirement set. And one, knowing how complicated that the South Polar region is from the perspective of light and the terrain, we want to be able to get close enough to the locations where we want to do the work. So working with our science community, working with our technology community, we want to be able to land close enough, even on this first mission, that we can get out and be right at the places that we want to work. So we worked through that, and that was what we put into our requirement set for the HLS, prior to SpaceX being selected. So that's what we're trying to do, is make sure that we're close enough to the target locations we want to be able to get to, and then we can better plan a mission from that perspective.
Thank you. Our next question is from Steve Gorman of Reuters.
Yeah, hi. Thank you for doing this. I had a question. How much, if any, manual control over the landing will the crew have for Artemis 3 and for subsequent missions?
Yeah, another great question. The Starship will have manual control, so the crew will have some capability. What we want to do is any specific questions about Starship capabilities today, since we didn't include SpaceX, we want to reach out to SpaceX. So we're going to get our NASA comm folks to help you do that today.
Thanks, Mark. Let's see. Our next question is from Megan Bartles of Space.com.
Hi, thanks so much for taking my question, which I think is for Jake, but if others want to chime in, that's great. Now that you have candidate regions, will LRO be tasked to investigate those, and what might that work look like?
Yeah, good question. So the Lunar Reconnaissance Orbiter is not currently in an orbit that will enable us to image these sites. But part of what went into some of our considerations for sites was the basis of availability of data so that we can meet some of our other considerations. So being able to look at the roughness of the surface, for instance. So the sites that we're talking about are places that the Lunar Reconnaissance Orbiter, based on a heritage of discussions that are documented in the community over many, many years, these are places that we have targeted specifically with LRO already. So we can't target these locations again with the Lunar Reconnaissance Orbiter, but we have targeted them specifically in the past.
Thank you. Our next question is from Michael Greshko of National Geographic.
Hi, thanks for taking my question. I think this one might be for Jake as well, but anybody can chime in. How has the decision to delay the Viper rover to a late 2024 launch affected or changed the plan for evaluating these potential candidate landing sites for, among other things, their volatiles? Thanks.
So I think I'll take that. So I think, Viper is of course, a necessary first step towards understanding the resources available. But we do actually have a lot of information about where we think those resources are from our science community, from orbital capabilities like LRO, but also from modeling and within our science community. And so we actually have quite a bit of information. Of course, we want ground truth from Viper, and that's really going to help us. But in terms of being able to select landing sites, we don't need Viper's data.
Thank you. Our next question is from Marvin Marshall of Nighttime News Space Report.
Hi, my name is Marvin Marshall from the Nighttime News Space Report on Twitch here. This is for Jacob or anyone who wants to answer here. It's from one of my viewers named Joe. Joe wants to know, are you guys planning on visiting any of the old Apollo sites on a detour to learn about the wear and tear on instruments and equipment that may have been up there for, over 50 years now, exposed to the lunar space there? Thank you.
Yeah, this is Jake. I'll take a first cut at that. That is a very interesting topic, and we have discussed the value of doing that. And as your viewer has noted, there is value in understanding what has happened to the hardware that has been on the lunar surface for that long. But we also are very interested in protecting the Apollo sites. They're referred to as heritage sites on the lunar surface, and we actually have some public documentation about that. So they're somewhat protected regions, although we do have the potential to use them if there's something that we need to learn. But we can also begin to learn about some of those processes by having a regular cadence of landings in the South Polar region. We can leave witness plates, for instance, to understand the impact on the surface. Especially if we get to a point where we're landing, at or near the same location, we can revisit those. We don't rule out the option of potentially going elsewhere, but right now our focus is at the South Polar region for Artemis 3, and these 13 regions are the places that we are now trying to assess further, and as Mark indicated earlier, try to get to a shorter list, as short as we can.
Thank you. Our next question is from Thomas Schumann of Radio Fall, Denmark.
Yeah, hello, and thank you for taking my question. I don't quite know who would be able to answer this, but I'm wondering what the astronauts would need to train in to explore the permanently shattered craters. What are some of the unique things they would need to train for?
Yeah, this is Jake again. I can start that answer, and maybe others have some additional input. We have to learn how to operate in some of these locations that are unique, of which, as you know, the permanently shadowed locations, they are certainly a unique aspect to the polar region. One of the things, I think Sarah noted this already, and I did earlier as well, these permanently shadowed locations may contain volatiles, frozen volatiles, in fact, that maybe we can go sample and begin to learn about. So we have a lot of questions about these permanently shadowed locations. What is the makeup, what is the relationship of volatiles and the regolith? What is the surface roughness inside these craters? Can we get down to the volatiles? Is there enough volatile there that we can actually sample it and or potentially extract larger volumes of it in the future? These are all questions we have. So the skill sets needed to do that will most likely fundamentally be, from a science perspective, understanding the geoscience aspects to it. So kind of your traditional field science skills we'll need to use there. But we're also going to have to learn how to operate in that total darkness on the lunar surface. So we do have questions about how much reflected light might go into these locations. And how do we actually navigate and work inside there? And actually, how cold do they get at the scale of a person walking around? These are all questions we have. So permanently shadowed locations, regions, will certainly be a target of interest for us, trying to just understand them, understand what they hold for us from a science perspective and from a resource perspective, and in general, just starting to learn how to operate in there. So that's kind of what we're going to have to bring forward.
Yeah, and I can add to that, Jake, that it's not just operating in these permanently shadowed regions, but understanding how to do field geology in these extreme lighting conditions, even outside of these permanently shadowed craters, is going to be a challenge. And so we're actually practicing. We're, going out at night and doing analog activities where we bring our own sun and we test out the lights on the suits and make sure that our astronauts can actually see the geology that they're trying to study. And so we are actually already in practicing that and trying to learn how to do that and to optimize the situation for the astronauts when they get there.
Thank you. Our next question is from Manuel Manzanti from Debate.
Hi, good afternoon. How are you? Sorry, I apologize if you mentioned this during the presentation. I wonder that given that you took the decision along with SpaceX of these 13 places, I wonder if is it safe to assume that the first HLS demo flight will land in one of these places?
The uncrewed demo flight, yeah, great question. We have a different arrangement for the uncrewed demo flight. SpaceX will actually lead the selection of where they land on the uncrewed mission. We have asked them, they will land at a similar location between 84 and 90 degrees, so again, within 6 degrees of the South Pole, but they will lead the selection. They may or may not use the same set of constraints, and they will make the primary selection, and they will coordinate a course for us, so we may iterate on it, but that's their responsibility. It will likely not be one of these 13 sites, but in the same region. And they're not required to use one of these 13 sites.
Thank you. Our next question is from Leo Emright of Irish Television. Leo, your line is open. Can you hear us? All right, Leo, we cannot hear you, so if you are having issues with your audio, you can rejoin the queue. We'll go now to another question from Marcia Dunn of the Associated Press.
Yes, probably for Mark. I know you mentioned the first woman is going to be on this crew, but we also keep hearing about the first person of color. Is that a requirement for the first landing crew? Is it a desire, or is that TBT?
Yeah, thank you, Marcia. Thanks. I know a lot of people talk about both those. So we know on the first mission we are going to land a woman, and whether or not that woman will be a person of color or either of the two crew members will be a person of color, that's not a mandatory requirement for the first mission. Could happen. It could be one of the subsequent missions.
Thank you, Mark. We'll take another question from Steve Gorman of Reuters.
Yeah, hi. I wanted to know, are all these 13 regions considered kind of like equal contenders, or are there one or several of them that are kind of maybe are more promising to you even at this point? And I wonder if you could also go through again some of the craters that they surround. You kind of rattled off names of craters early on before I was trying to get this picture up. But
yeah, so I could go through the list again. So let me go through the list first, and then we can get to the first part of your question. Again, for everybody, you can also refer to the image that we have released about an hour before the beginning of this teleconference. But the 13 regions that we're looking at are the rim of Amundsen crater, the northeastern rim of the Nobile crater. On the image, we call that Nobile 2. The western rim of Nobile crater, we call that Nobile 1 on the image. The Leibniz Beta Plateau, the rim of Faustini crater. There's an elevated region between the Shackleton crater and the Slater crater. The Malapert Massif, there are 2 locations along a high-standing ridge, and that ridge connects the Shackleton and the Dagerlosh craters. There's a location on the rim of Hallworth crater. There are 2 locations along the rim of Dagerlosh crater itself, and there's a massif between the Dagerlosh crater and the Coker craters. Now, as I mentioned in the introduction, these are 13 regions that are favorable from our perspective with respect to the landing considerations that we talked about. So these are places that we can get to. So those are kind of what we need to learn about to see where we can go. And so now, again, one of the reasons that we're trying to engage the community now and announce these regions is so we can start a dialogue with the community, as Sarah was talking about. If we get to the point where we know we could go to 2 places at the same opportunity, then maybe we can weigh in the value between those 2 locations. But that's part of the work that we have to do going forward, in addition to working with SpaceX to further evaluate these 13 regions.
Thank you. We're going to try to go back to Leo Emright of Irish Television.
Thanks. I hope you're hearing me now.
Yes, thank you.
Sorry about that. Yeah, I'm still a little bit, I'm trying to get my head around these moving opportunities, because if you spool the image that shows us the 13 candidate landing regions is one instant in a 2-week cycle. And if you spool around with that video, only 2 of these sites are visible at any time. They all, they disappear into darkness constantly. So you're talking here about target regions, each one of which only has, it would seem, 4 or 5 days at most where they're fully lit. I mean, you're really trying to thread a needle here, and I'm trying to understand how you do that and keep an astronaut crew safe.
So this is Jake. I can start to answer that question. You are characterizing exactly the challenge that we're dealing with right now. And, as I mentioned in my opening, the Apollo missions took full advantage of the lighting conditions near the equator, knowing that they would have the equivalent of 14 continuous Earth days of light once per month. So they could land in those locations and know that they would have a stretch of 9-10 days of light. But you touched on exactly the difference with the South Polar region. Any of these locations is not in light all the time, neither were the equatorial regions. So we have to model and understand exactly when they do enter into light and for how long. And so one of the conditions we're looking at is that it would need to be in light for Artemis 3 throughout the duration of the mission. As Mark talked about, it's between 6 and 7 day long mission. So we need that stretch of sunlight, but that's really all we need. So it could be in darkness much of the rest of the time, but if it comes into light for that period of time at the right launch opportunity, we could go there. That's why we're looking at a number of sites, not narrowed down to a specific single one at this point. We have 13 regions, each of which include multiple sites. And as you said, we're trying to look at how we thread that needle. And then, as Mark said, how can we try to reduce that number from 13 down to a smaller number by better understanding with our modeling and also working with SpaceX to bring them into that conversation as well.
Thank you. We'll now take a question from Marcia Smith of Space Policy Online.
Thanks so much. And I want to follow up on that a bit. I'm wondering what the contingency plans are in case something goes awry. So if you have a 6 or 7 day mission and you choose a window when the landing site only has 6 or 7 days of daylight and you can't get off for some reason, maybe you need an extra day to fix something. I mean, are you factoring in any margins in this just in case the liftoff from the surface doesn't go as planned? And just more generally speaking, what are the contingency plans? How long could they stay on the surface if they needed to?
Oh, yes, Marcia. You know, NASA, we look extensively, and by the way, this is Mark, by the way. Marcia, we look at all sorts of contingencies, ranging from, you know, when we're sitting on the ground, SLS Orion is sitting on the Earth, and we miss a launch window and have to go to the next one, so we're looking at that. That's why we have multiple sites, multiple regions. And then once we are on the surface of the moon, we're looking at contingencies. First of all, what if we have to leave the surface of the moon before the optimal point to leave, which is 6.5 days? So let's say we land on the moon, something goes wrong, we have to leave an hour later. We have a plan for that. If we have to leave a day or 2 or 3 into our stay, we look at that. And then we also are looking at what happens if we miss our 6.5 day and have to spend another 6.5 days. So all of those are part of our contingency planning process.
Thank you, Mark. Our next question is from Zach Aubert of Launchpad News.
Yes, Zach Aubert with TLP Network and Launchpad News. Thank you so much for doing this. Somewhat of a different question. We know that China and Russia are both also looking towards the South Pole with planned rovers and different types of probes and stuff in the coming years, kind of on a similar timeline. I guess what type of considerations they're looking at where they're going versus where NASA is planning on going, and if there's any cooperation or difference, and is announcing these sites maybe something kind of saying like this is where we're going and hoping they kind of stay away? Obviously, space is better together, but just curious your thoughts there. Thank you.
Yeah, I can take this one. This is Jake. So in general, international participation is a part of Artemis, and in fact we have the Artemis Accords, which a number of nations have already signed. And we are looking at working in a collaborative manner. And a number of our international partners are, in fact, having conversations with us about their vision for what the Artemis architecture would look like, what contributions they could make. Additionally, we've held a number of workshops. Sarah Noble from SMD, as well as many other folks from SMD, the Science Mission Directorate, have held a number of workshops that have asked the community about places we might want to go, what types of activities we might want to be doing, and international partners have taken place there as well. So we do have a fairly good perception of what many of our international partners are thinking. But, you know, the point of the presentation here today was to, you know, explain what some of the complications are for the South Polar region that we have to anticipate. And right now, as you can see, we have 13 regions, and, you know, some of the questions ahead about, well, you know, how hard is it to go to some of these? And it's not that it's any harder than going and landing elsewhere on the moon, but we do have to take into account some of these environmental conditions, which do in some ways constrain when we can land in certain places. So right now we're carrying a fairly large list. We do know that other nations are considering where they might want to go, and you know, they're working through these complications the same as we are. And you know, if they can go and land, we'll be watching where they go. But we've got these 13 that we're working on now with SpaceX. We're trying to evaluate them, get a better understanding for when we can get to which ones, and then also, again, by talking today about this, encouraging that we can work with the science community, including partners from around the globe, to talk about what they think is the value of going to some of these locations. So, you know, at this point, we're working hard as a community, trying to just narrow our list down and get to where we can. But as I also noted, each one of these regions has multiple sites within it that could be considered. So I'm not too worried about overlap. The moon's a big place, and we're going there to learn and study, as is everyone. And so we're just going to keep our mind focused on the task ahead of us, continue to evaluate these 13 regions, and work with the community to understand better from their perspective what the value of some of these places might be.
Thank you. We have time for one more question. We'll go to Jeff Faust again from Space News.
Thanks. Couple of quick follow-ups. One, you've mentioned that these landing regions have multiple landing sites. On average, how many landing sites are there in a given region? And then second, are you counting on data from any future missions to support the site selection process? I assume you'll take in the data that comes in from any of these missions as they develop, but is the site selection process dependent on getting data from future orbiter missions or CLPS missions or the like? Thanks.
Yes, this is Jake again. Thanks, Jeff. Good questions. So, each one of these regions has a different number of potential sites there, and it all really comes down to those questions or those conditions that we talked about. But, there's at least 10 in each one of these, and in many of them there are more than that, again. So we're just trying to get a handle on the regions right now and the timing at those regions before we even get into those specific details. As for data that we need, we don't need additional data in order to land this Artemis 3 mission. The Lunar Reconnaissance Orbiter did a great job, as well as the orbiters ahead of it. There will be activities such as Viper. Viper was brought up already, that will help us understand what those environmental conditions are like. Anytime we would go to the polar region, it will help us constrain our models on the lighting there. So any data is helpful, and we're happy to have it, but we don't require additional data in order to complete an Artemis 3 landing at these 13 regions at this time.
Thank you, and thank you all to our speakers and to the reporters on the line. We'll now go to Mark Kiersich for a few closing remarks.
Thank you, Catherine, and thanks to everybody who came to listen today. You can tell Jake, Sarah, Prasan, and I are all extremely excited about it. There's been a lot of work to date. We have a lot of work to go. We're going to be working together to find the best site that works for all of us. And you heard Sarah describe today how we are looking for external inputs. When we bring humans back to the moon, we want it to reflect the inputs and thoughts from the best and the brightest and the people who are passionate about this. So we are looking forward to the conferences that we have upcoming to help get other inputs to think about things we haven't thought about yet. And with that, you've heard about us thinking about Artemis 3. We want to go back. I'm going to start slowing down a bit and putting my attention towards Artemis 1. I'm heading to the Cape next Wednesday, and we're really looking forward to the kickoff of this series of missions a week from Monday with Artemis 1 and the launch of SLS and Orion. So thanks again for your time, and appreciate it.
Thank you again for joining us today. You can listen to a replay of this recording on NASA's YouTube. Be sure to read our news release on the candidate landing regions for Artemis 3, available on nasa.gov, as well as follow along with updates on the upcoming Artemis 1 mission by following our Artemis blog at blogs.nasa.gov/Artemis. And if there are any additional questions, we couldn't get to all of the questions in the queue today, you can email the public affairs contacts on that news release, and we'll be happy to get you additional information. Thank you all, and have a great afternoon.
That concludes today's conference. Thank you for participating. You may disconnect at this time.